Okay, here's a third quick video. This one is about substitution. So when we have some polynomial or any equation that has a variable in it, if we want to know what it actually equals, we need to learn what that variable is. So if they tell us what that variable is, they say x is 3 or a is 27 or whatever, we can always just plug it in, substitute, and figure it out, solve it. So if we want to evaluate 3a squared plus 2a plus 7, and they tell us x is 3, so we'll do this part here later. When they tell us x is 3, well, that's no good. They have to tell us a is 3, don't they? That's pretty sloppy. So when a is 3, then we would say 3a squared plus 2a plus 7. When a is 3, everywhere there was an a, we throw in a 3. I'm doing it in brackets because I want to make sure that I have a good habit for when I deal with negative numbers. So 3 times 3 squared plus 2 times 3 plus 7, we use our order of operations. You may have learned it as BEDMAS or BOMDAS or PEMDAS or whatever. It's the same. Order of operations is one of the few things people seem to be able to agree on. So first we do our exponents. Well, there's no brackets to be done. We have some exponents here, 3 squared. So this is 3 times 3 squared. 3 times 3 is 9. But it's in brackets too. I'll do the same style. And now we do our multiplication from left to right. 3 times 9 will be 27. 2 times 3 will be 6. And 27 and 6 is 33. And 33 plus 7 is going to be 40. If we do the exact same thing, but not with a equals 3, but a equals negative 3. It's similar, just everywhere that we had a 3, we're going to put in, the green doesn't show up very well there, does it? We'll put in negative. Well, pay attention a little bit here. So, just take these out. This entire last couple of lines I got to get rid of too. And also the answer. If you want to go back and look at that answer, you can always rewind. So 3 times negative 3 squared plus 2 times negative 3 plus 7. We still do our exponents first. Negative 3 times negative 3 is 9. 3 times 9 is 27. That didn't change from before. And 2 times negative 3, is negative 6. And now if we have 27 and negative 6, we should get 21. 21 and 7 is going to be 28. So a different answer because we had a different variable, but the same technique, just wherever there was an a, throw in the number that they tell you. We'll do another one here, draw a line so we know we're separate. If we have 3x squared minus 2y cubed, let's do this first one here. When x is 2 and y is 1, this is 3 times 2 squared minus 2 times 1 cubed. We'll do our exponents. 2 squared is 4, and 1 cubed is 1. Now we'll do our multiplication. 3 times 4 is 12, 2 times 1 is 2, and 12 minus 2 is going to be 10. If we do this one now, where x is negative 1 and y is 0, all we do is where there was an x, we'll put in a negative 1. And where there was a y, we'll put in a 0. So that's going to change everything below. But it doesn't make it any harder. So we'll do our exponent here, negative 1 squared. Negative 1 times negative 1 is positive 1. 0 cubed is, let me check, 0 times 0 times 0, that's still going to be 0. 3 times 1 is 3, 2 times 0 is 0, 3 minus 0 is 3. So again, we get a different result, but of course that's to be expected. We have different values for our variables. There's nothing tricky about evaluation other than remembering all of your order of operations details, which can get tricky on its own. We'll do one last one here before I go. 3 times a minus b plus 8. I'll show you a couple of ways to do this. So 3 times a minus b plus 8. Let's do the first one here. A is 5 and b is 4. So that's a 5 and that's a 4. Now we can do this, we have kind of two paths here. One is to do 5 minus 4 inside the brackets, which is what you should do. I mean, you should do your brackets before you do anything else. So 5 minus 4 is 1, still multiplied by 3, still having 8 added to it. 3 times 1 is 3. We get 11. This is the way that I would recommend you do. But I'm going to show another way which just emphasizes another skill. We talked about distribution in an earlier video. So if we do 3 times 5 and 3 times negative 4, if we distribute the 3 on the outside of the bracket to the inside, we should get the same result. Just make sure that works. So if we do 3 times 5, and 3 times negative 4, so minus 3 times 4, and then add 8. We still have 3 times 5 is 15. And 3 times 4 is 12. 15 minus 12 should be 3. And 3 plus 8 is still 11. We get the same result. This way, again, I think you should do. I think it's less work, less likely to go wrong. But if we do this, where we do the distributive property, it still works, and that's a good thing to remember about. There's more than one way to solve any given problem. If we do the same thing for a is negative 3 and b is 2, a is negative 3 and b is 2. Now I'll do both ways again. Let's get rid of this previous stuff. So we could do negative 3 minus 2. So negative 3 minus 2 is negative 5. 3 times negative 5 is negative 15. And if we add 8, we get negative 7. If we do it the other way, where we distribute, we have 3 times negative 3 minus 3 times 2. I'll have to write it out like this. 3 times negative 3 is negative 9. 3 times 2 is 6. And negative 9 minus 6 is negative 15. Negative 15 plus 8 is still negative 7, just like it was before. So you've got these two paths. I recommend getting familiar with both of them. They may help. Okay, I'll see you in the next video.